So welcome everyone to a brand new session of No Planet B. Did you know, according to the Composite Water Management Index, a report prepared by the Niti Aayog in 2018, it says that India is facing one of its worst water crisis. 600 million people are facing water shortages in our country, and 70% of our water are contaminated. With that thought, let me welcome Swapnil Srivastav, the co-founder of Uravu Labs, a Bangalore-based water tech startup founded in 2019, bringing in solutions to solve the water crisis of our country. You know how? They bring water from thin air. Yes, you're right. So let's welcome Swapnil to our session. He's right here. Hi. Hi, Swapnil. How are you?
Thank you.
I had given... No, my pleasure. I had given a slight introduction about Uravu Labs, but let me elaborate it a little bit for our viewers. So Uravu Lab is challenging the conventional approach to water scarcity by bringing in an innovative technology, that is water from air systems. So desiccant materials like silica is used to absorb water from air, and heating is provided to extract the water in liquid form from this material. And for the heating technologies, renewable sources such as solar energy is used, and this makes Uravu Lab 100% renewable water to air solution. I hope I got the process right. My question to you, Swapnil, is what makes the technology by Uravu Lab different and in a way better compared to the other water from air technologies in market today?
Sure. Yeah. So that's a very interesting question, and like one of the important questions which actually differentiates us from many of the technologies out there. So if you look at the whole water from air landscape, it's not a very new concept. Many companies have existed and solutions have been there for almost 2 decades now. And in this space, there are almost 200 companies operating. Very small companies, highly fragmented market, but still like a small and growing market. But most of the companies in this space, I would say more than 99% of these companies in this space use a technology which is based on air conditioning effect. So you would have seen, air conditioners, and if you run them for, a couple of hours, you will see water dripping from the air conditioners.
Yes.
So what in this is, there is moisture in the air, and when you pass it over a very cold surface, that moisture is just condensing to liquid water. And, that's what most of these atmospheric air to water companies do. Now, the problem with this technology is it's highly energy intensive. All our air conditioners consumes huge amount of power. So similarly, these are very high energy consumption, and till today, most of our electricity, these require electricity to run, and most of our electricity still comes from fossil powered grid. So be a coal plant or natural gas plant. So these technologies by nature are not renewable as a sustainable technology should be. So they for every liter of water produced, around 100 to 500 grams of CO2 is released. So it kills the purpose of having a more renewable or a sustainable technology in the water space. So when we started, we were actually first doing a similar technology. We are trying to figure out what's the drawbacks of such a technology, and we had made some couple of prototypes also in our initial years. So we quickly realized that power consumption is one problem. Another problem is also when your relative humidity conditions, which is the RH of a place, which is equivalent to the moisture levels in the air, when they drop below 50 to 60%, the power consumption increases much more, and your water production decreases. So it becomes less effective in lower RH conditions. So these were the two potential drawbacks we saw. So we started something which is a different technology, which uses, as you were mentioning, something like desiccants. Desiccants are actually water vapor loving materials which have very high affinity for moisture in the air. So when you pass air over it, these desiccant materials will start absorbing this moisture. And we use something called we have experimented with silica gel, which are like solid desiccants. We are also working with liquid desiccants like calcium chloride. So these materials have affinity for water vapor, and when you pass air over it, it will absorb this moisture in its 3D structure. Now once that absorption part is done, we will have to then heat these materials up to release that vapor. So now for making water 100% renewable, there are two aspects which need to be fulfilled. One is you're sourcing water from an inexhaustible source, which in our case is air for most water from air technologies. But the second aspect, which is the power or energy which goes in harnessing that water, should also come from renewable energy sources. So which in our case, we typically require heat at about 70 degrees Celsius to heat these materials. So that heat can come from solar energy. It can also come from waste heat from industries, or it can also come from biomass waste. So we, try to utilize these kind of renewable energy sources to then heat up the desiccant to about 70, 80 degrees Celsius, and then release this water and then collect it as fresh water. So that's how typically, the whole process works. And it runs in, cycles of, first is absorption, then desorption, absorption, desorption. So throughout the day, based on the system design, we can produce any amount of water, and the technology is scalable from right from just 10-20 liters per day to even tens of thousands of liters per day.
Oh wow. Okay. So I would like to ask you this question. Like in India, the situation, it's real bad. Like we are going through a water crisis. On one hand, we are depleting our groundwater, and on the other hand, we are polluting our rivers. And though there are many government initiatives to increase the water supply and sanitation, not much focus is given towards water resilience, which is where Uravu lab comes in. So in a country like India, which is large and a developing nation, how do you think a technology such as Uravu lab can solve the water crisis? Because scalability and affordability becomes the major concerns.
So, as you rightly pointed out, right? India is actually one of the countries which is suffering from water stress, water scarcity, but it's not alone. Many developing countries and even now developed countries are seeing effects of water depletion, climate change, and groundwater has been not just available in terms of volume, but also quality has been really bad. So to solve this whole thing, it won't be a play of just one technology being a silver bullet solution. It will also need many of these stakeholders, whether that be government, even corporates, even consumers alike, to come together and look at a portfolio of solutions which can best solve their local problems. So unlike CO2 emissions, which is a single measure which could be followed as a standard, water problems tend to be more localized. What might work and might not work very well in somewhere in Kerala, or for together maybe in California. So but then water from air, when we look at it, water from air as a technology, we see that it could be a stepping stone to adoption of newer technologies, which can find a way to at least cater to their drinking water needs. So water from air, from a cost perspective, it's always it's going to be slightly expensive than say just drawing out a groundwater and filtering it. So we are positioning it so that it tries to solve most of our drinking water needs, which is where the need is for very high quality drinking water, and where accessibility is also a problem. Plus there are many industries which can start using renewable water. So if you look at today, groundwater is a major source where India is dependent on. Most of our agriculture is done through groundwater. 85% of Indians drink groundwater, and after certain purification. So what happens in these kind of scenarios is there are many industries which, say agriculture, they can't wean off their requirement from groundwater because they require that cheap source of water. But there are industries like the beverage industry where like they can typically look into how we can utilize a more renewable source even if it's slightly costlier, and then have products take up that pricing. So it will take like a effort from all these kind of stakeholders, and especially government has to either try to subsidize these technologies,
Subsidize.
or come up with policies where it becomes more attractive to corporates to adopt these newer technologies. Because as of today the mentality is okay, let's keep on using groundwater till the point it's dry. It's this many of these problems are still 5, 10, 20 years away, so why bother today? So that's
True.
where I think government intervention should come in, and that's where I think technologies like what Uravu is offering could be promoted and could become like a part of that whole tool of solutions.
So are there any existing subsidies or government funds for water tech startups? Are there anyone existing ones?
Not really. Like so there are like there are some agencies like Ministry of New and Renewable Energy, which have typically come up with these policies or subsidy support. So around 15 years back they did that for solar thermal and solar PV. Now they're doing it for solar pumps. So water is something which they've tried. Now they've started looking into it, and they're trying to come up with okay, what could be the most appropriate solutions which could actually be utilize that subsidy model as well, because
Okay.
these are usually for newer technologies which need further adoption. So like reverse osmosis or kind of filtration technologies, they have been there for many years, so they don't require as such subsidies. They have already reached a price point where they are mostly affordable. They are made by many players. But then when you come to some technologies like water from air, these are quite new as such, where adoption
True.
is still where there is much more scope to reduce the cost further. So I
True.
think government is taking steps. We have also had good positive conversations where they are trying to promote these newer technologies, and also looking at alternatives like desalination or wastewater treatment as well. So government support is going to be there. Let's see when it comes.
Congrats on your recent pre-seed fundraising round. Congrats. And also your association with the AB in Bev, a leading beverage company. And yeah, you had slightly mentioned previously that you are looking into solving drinking water solutions problems. So yes, and industries such as beverage industries are they have a huge demand for drinking water. But apart from these, are there any concerns that made you focus into this industry itself? Are there any environmental factors, or did you find any other impacts that can be solved by focusing into the beverage industry?
Sure. So when we typically look at the beverage industry as a whole, it consumes almost 1,500 billion liters of water into the end products.
Okay.
This 1,500 billion liters is equivalent to 20% of yearly human drinking water needs. So like that itself is a huge number, and more than 45% of this 1,500 billion liters per annum comes from groundwater sources. So you take
Okay.
top companies in the world, Coca-Cola, Pepsi, AB InBev, Diageo, many other companies. If you look at their water consumption profile, we find that more than 45-50% is coming from groundwater sources. Now, one reason to typically look at, and in another part also, as a business, as a startup, you also have to look at markets which can find use cases and applications from the even from the lower stages. So when we see the beverage industry, it's almost a $2 trillion industry worldwide, and even in this there are many more semi-premium, premium sectors which can absorb this cost of high cost of the renewable water, especially in the early phases. So when we typically start any new technology, we are doing it in low volumes, but we are trying to applications where higher pricing and higher profit could be achieved. because
Okay.
if you look at just drinking water, say you want to make sure that this water is useful for say some rural areas, but then there people require as affordable water as possible. So
True.
so there's not a direct commercial case there, maybe, but then if the government intervenes and they are able to pay for that equipment and reduce the capex, then only it becomes affordable. But we wanted to first try out applications where there is a commercial application, it makes commercial sense, and beverage industry stood out in a way that there is not just from a utility perspective they're looking at high quality water. Many of these corporates today have very strong sustainability agenda. They have ESG SDG goals where they are trying to reduce their overall fresh water consumption. They are looking at alternative solutions which can reduce the demand for fresh water in their manufacturing facilities. So that's where it becomes and many of these corporates are themselves scouting out startups. So this is what I've seen where nowadays startups are also kind of more not startups, but these corporates also are more aware of that they need to find more unique solutions, and especially for the ones which they don't have any expertise in. Water from air, very more like a deep tech solution where many of these corporates don't have any background or expertise in, so they're looking for startups to do that. So that's where we think beverage industry was one like a sweet spot for us, where we could
Please continue. There was a slight network glitch, but please continue.
so I was telling, so beverage industry is somewhere where we can find these applications where volumes could be slightly lower, especially in the early stages, but then you can have higher margins, higher growth in that way. Plus, the one thing I just wanted to add extra in this beverage industry was, water from air also has a more perceived value or like an emotional pull to it. Like when you say that suppose. So there was one example where AB InBev actually made a Budweiser beer, and it had the trademark which said brewed with 100% renewable electricity. So
Okay.
it's like many of their breweries had started using wind power and 100% so, but then when you drink like a can of beer, you don't realize that it was made with renewable electricity because it's intangible. But then water is something tangible, and when you have say a similar logo which says 100% renewable water, a consumer can say drinking 100% renewable water. So that's how to AB InBev also, and that's where this idea came that renewable water also holds a more tangible and perceived value where consumers can start also relating to it, and so that's where we think one of the other components, which is to educate the consumer, that also gets fulfilled along the way when we do beverage industry, because newer technologies need that if we want that adoption curve to grow, that awareness and
Very true.
very important.
Getting the word out there, and true. And then people are still it's a new concept, 100% renewable water, so so I had this question, I lost it somewhere. I wanted to know whether you have to filter the water after the disposition process, or you can directly use it for consumption. Are there filtrations?
So what happens, like even before we start the process, we use something called HEPA air filters. So these air filters typically used in ICUs and even nowadays in our home air purifiers. So they can any of these pollutants, PM 2.5, a lot of bacteria, viruses, and so the air which interacts with desiccant is already 100% pure, or at least 98%. But then when we heat it to up to 70 degrees Celsius, so suppose there would be
bacteria,
microbial life still left, it would also die away. And then finally we collect this fresh water. Now to make sure that like we have this extra safety layer, we pass it through a UV disinfection chamber, and then we also mineralize it to make it potable for drinking, because air naturally doesn't contain any minerals or ions, so the water you get is actually just distilled water. You can't add it. So when we pass it through a mineral cartridge, and it becomes potable for human consumption.
Okay, got it. Thank you. That comes to the end of this session. So thank you, Swapnil. Thank you so much for saying yes to this session. And to our viewers here, I must mention that Swapnil is a senior of mine from NIT Calicut. So it makes me immensely happy to see Uravu Labs going places. I wish you and your team all the very best and keep inspiring us.
Sure. Yeah. No, it's a pleasure of mine to be here with you and speak to you. Thank you for the opportunity.
Thank you. And thank you to our lovely viewers. Stay tuned for more sessions. Thank you, Swapnil. Bye.